Hello and welcome to my YouTube channel. In this playlist, we are talking about programming in C language, and today we are going to see how to do bitwise operations using C language. So let's start the video. So what are bitwise operators? Basically, we know that all the computers and all other digital devices store the data in the form of sequences of ones and zeros. When we say sequence of ones and zeros, for example, if you are storing 5 in the computer, then in that case it will be stored in this form. This is the hexadecimal form of decimal 5. So in the same way, all the numbers, characters, floating points, all these variables are stored in the sequence of zeros and ones. So these are all called bits of the data. So zeros are bits, ones are bits. So all the variables are stored in the form of bits. So C language uses 6 different bitwise operators. So these 6 bitwise operators are used to manipulate or change the data in C language. So in the data, you can change any particular bit by using these 6 bitwise operators. So which are these 6 bitwise operators? So the first one is your AND operator. So this is called bitwise AND operator, and this is generally used to make individual bit or set of bits low. Remember, so this is very important, that AND operation is generally used to make a particular bit or set of bits low. We call it bitwise masking also. Then we have this pipe symbol, which is used for bitwise inclusive or we can say OR operation. It is generally used to make individual bit or set of bits high. It is just opposite to that of AND operation. In AND operation, we make the bits low, whereas in OR operation, we make the bits high. Third operation is our bitwise XOR operation. XOR operation is used to set 1 in a particular bit position when the operands have different bits, and zeros when the bits are same. We will go through the example to understand this concept. So remember, whenever you have 2 bits which are same, the result of XOR will be 0. But when the bits are different, you will get 1 in the result after doing XOR operation. Then we have the fourth operation, which is bitwise left shifting. So this particular operation is used to shift the bits towards left position by a recommended number, which is provided by the user. So if we use this particular operation, then we can shift the bits from right to left position. Similarly, bitwise right operation, this is used to shift the bits from left towards right position. So we can shift the position of ones and zeros towards right by using bitwise right shift operation. And last is our ones complement. Ones complement is used to just complement the zeros and ones. What does that mean? It means after using this operation, all the zeros in the data will become 1 and all the ones in the data will become 0. So we are just complementing the zeros and ones using this particular operation. One thing that you must remember using bitwise operation is that we cannot perform bitwise operation on floating numbers. So floating numbers cannot be used for bitwise operation. This is one important concept to remember. So let us go through a simple example and try to understand how to write a program which can accommodate all these 6 operations, and we can see how these 6 operations actually manipulate or changes the data in our C language. So here I have written a program which performs all these 6 operations. So what is there in this program? So just briefly let me discuss about the program. Here I am declaring a variable A, B, C and D. So A is initialized with the value FF, B is initialized with the value AA, C is initialized with the value 88. So in short, if we want to look into the data, then FF in hexadecimal is 11111111. Okay. Similarly, AA in hexadecimal is equal to 10101010, and then C, which is containing 88 in hexadecimal, is equal to 10001000. So we can do all the bitwise operations on these numbers, and let's see what is the result or what is the outcome. So first of all, I have compiled the program. So by rebuilding the program, and I can see there is no error, only 2 warnings are there. We can neglect the warnings. So let us go through the program step by step. Here I am using the watch window. Okay, in the watch window I can check all the variables. So first let me go through the initialization. A, B, C and D, these are our variables. Right now all these variables are garbage values. So, and that too, these variables are shown in the decimal number system. So right click on the variables and then go to properties and make them binary. Okay, let us repeat this thing. So right click on the variable, properties, make them binary, because only after that we can check the effect of these operations on the binary numbers. So let me make all of them binary. Done. So this is done. So now right now the all the variables are having the values. So FF is 11111111, and similarly B is 10101010. Okay, and C is 10001000. Okay, so let us start the programming. So here first of all I am going for bitwise and operation. So D is equal to A and B. So if we perform the AND operation between A and B, then all the multiplication between 1 and 0 will result in 0. 1 and 1 will be 1, 1, 0, 0 and so on. So let us check the content of D. So here you can see 1 multiplied by 0 you get 0, 1 multiplied by 1 you get 1, 1 multiplied by 0 you get 0. So indirectly what we are doing in these particular bit position, we are introducing 0 or forcing 0 to introduce on those positions. So this is why I called that bitwise AND operation is used to make a particular bit 0. Okay, and then let us move. In the hexadecimal value, you can see here the value in D variable is AA in hexadecimal. Okay, so D variable is containing AA. Now coming to the next line. So D is equal to B and C. So B and C. So we are going to multiply B and C using bitwise operation. So 0 into 0 will be 0, 1 into 0 will be 0. So here in this position we are forcefully going to introduce 0. Let us execute this particular line, and you can see here that multiplication of B and C. So 0 into 0, 0, 1 into 0, 0, 0 into 0, 0, 1 into 1, 1. So forcefully I am changing the second bit position to 0. This way, by using AND operation, we can forcefully change a particular bit to 0. Now coming to the bitwise OR operation. In this, first of all, let us go through this instruction. D is equal to A or B. So what we are going to do is, we are going to OR operation. So 1 plus 0 will be 1, 1 plus 1 will be 1, 1 plus 0 will be 1, 1 plus 1 will be 1. So in this way, wherever we have zeros, by introducing 1 or adding with 1, we can forcefully make it 1. So right now the D is 1000 1000. After executing this instruction, we can see we get all ones, because 1 plus 0 is 1, 1 plus 1 is 1, 1 plus 0 is 1, and so on. So all the zeros became 1. So forcefully we have changed the zeros to 1 using bitwise OR operation. Next, similarly, D is equal to B or C. So now when we are going for 0 plus 0, it will become 0, 1 plus 0, 1, 0 plus 0, 0, and so on. Let us try that. So here is the result. So bitwise ORing, 0 plus 0 is 0, 1 plus 0 is 1, and so on. So this is bitwise ORing, and bitwise ORing is used to forcefully bring a 0 at a particular bit position. Now coming to bitwise XOR. So bitwise XOR, the instruction is D is equal to A XOR B. So according to the rule, wherever we have same bits, we will get 0, and wherever we have different bits, we will get 1. So here we can see 1 0, therefore D here in this position should be 1, 1 1, because these are same bits, we will get 0 here. And similarly you can apply the same XOR operation on all bit positions. So let me execute that line, and you can see here wherever you have same bits, you are getting 0, and wherever you have different bits, you are getting 1. Next, B or C, XOR C. So B, here you can see 0 0, you will get 1, 1 0, you will get 0, and wherever you have similar bits, you will get 0, wherever you have different bits, you will get 1. Okay, so you might be having a doubt why we are not getting all 8 bits. So because if the numbers are starting with 0, then code block neglects those zeros. So it is basically 0 0 1 0 0 0 0 1 0. Okay. Now coming to the next instruction, bitwise left shifting. So right now I am going to introduce 0 1 in the B. So B is 0 1, and I am going to shift it by 1 position left. So if I shift it by 1 position left, we can see here in the D is equal to 1 has been shifted by 1 left position. So the D is 1 0. Okay. So 0 is introduced on the right end of the MSB of the number. Similarly, we have B is equal to 1 1. So B is equal to 1 1. So remember 1 1, when we say it is 0 0 0 1 0 0 0 1. All the preceding zeros are not shown in the code block. So it is, remember, it is 0 0 0 1 0 0 0 1. So let us left shift it. After left shifting it by 3 positions, you can see in the D you are getting, this one is shifted by 3 positions left. So you have 1 0 0 0, and this one is also shifted 3 positions left. So you have 1 0 0 0. So in the MSB position, in the LSB position, you are getting zeros introduced after left shifting operation. Now coming to the right shifting operation, again I am introducing 0 1 in the B, and I am going to right shift by 1 position. So let us check. So you can see the 1 is, the LSB of the 1 is taken out of the number, so the number remaining is 0. Similarly, if we go for another example, B is equal to 88. Now it will be much easier to understand. So 1 0 0 0 1 0 0 0. I am going to shift it by 2 positions right. So these ones will be shifted by 2 positions. So 1 will be shifted here, and this one will be shifted here. And in the MSB side, you will be getting new zeros. So the result in D should be 0 0 1 0 0 0 1 0. Let us try to execute this program, and here we have the result. So the result is 0 0 1 0 and then 0 0 1 0. So remember, the preceding zeros are not shown in the code block. So this way we can shift it by right or left. So now let us go for the complementing operation. So B is getting 0 and D is complement of B. So all the zeros will become 1 and ones will become 0. Remember, this code block is using 32-bit system. Therefore, all these numbers are represented in 32 bits. Okay, so 0 here it is basically 0 0 0 0 0 0 0 0. So similarly 32 zeros are there. Okay, so when we convert or when we complement it, we will get 32 ones in the result. Okay, so the answer basically is FFFF FFFF. So let me check. Right click, go to properties, and I can convert it to hexadecimal, and you can see here the result is FFFF 4 times and then FFFF 4 times. So total 8 F's are there. Okay, so each F is represented by 4 bits. So 32 bits are used in this code block system. So let me just show you in the console. You can see here the variable D is FFFF FFFF in hexadecimal. So this shows that code block is using 32-bit number system. So now last example. So we have B is equal to 1111 then 1111. Okay, so 1 means 0001, then 0001, 0001 and so on. Okay, let us complement the number, and here in the D you can see the number is E. So let us just change it to binary, and you can see the number becomes 1110, 1110, 1110. So all the zeros are complemented to 1 and ones are complemented to 0. So in this way we can do bitwise operations and manipulate the data in embedded systems, and not only in embedded system, in C programming and all other operations wherever it is needed. I hope you might have learned something new from this lecture, and if you like this video, then do post your comments and share your suggestions in the video and if you have not subscribed my channel, then I would request you to please subscribe my channel. Thank you and stay safe.